Bismillahirrahmanirrahim. Assalamu alaikum viewers and welcome to my channel. And in today's video we are going to handle the next or the second part of our trig sub integration. And in this part we are going to discuss the second type of the integrand that is going to take us towards the trigonometric substitution. And what is that integrand? Like, for example, if I say that I am having a function of this type, if a function is of this type, it could be within the under any kind of radical of any index, or it could be in simply written in this form, either in the numerator or in the denominator. If you are having a type of a function like this, then you are going to replace your x variable by means of this substitution or this substitution. Okay, so we have to focus on two examples here in this video. One deals with the definite integral and another one with the indefinite integral. Okay, so we are one by one we are going to have a look, and we are going to evaluate those two integrals involving an integrand of this type. Okay, so let's have a look at the very first example. Okay, so here you go, the very first example. This is an indefinite integral. You can see there that we are not having any kind of limits upper and lower on this elongated s. We are not having integral limits, so such kind of integration, such kind of integral is called the indefinite integral. And you can see here that in this function, what you say, the integrand, we are having a type of this format in the denominator, under a square root or under a radical of index 2. So we are going to replace our x by means of a sine theta, or you can use a cos theta as well. So let us see that we are going to assume that let x is equal to our a sine theta. Now we are going to differentiate both sides with respect to our original variable x. So once when we differentiate both sides with respect to x, this is a constant number, so we are going to write outside, we are going to write before the differential operator, and this is it. Okay, so you see this is your 1, the derivative of x with respect to x is 1. And the derivative of sine theta is your cosine theta, and then we are going to apply the chain rule on this variable with respect to x, like this. Now I'm going to shift this dx over here, and finally I'm going to have a format that dx is going to be replaced by our a cos theta d theta. Alright, so at the place of our x we are going to put down this, at the place of our dx we are going to put down this. Alright, so let's see. This x cubed upon under root a square minus x square dx is going to be written now in this form. At the place of x I'm writing my a sine theta whole cube upon under root a square minus, at the place of my x I'm going to write my a sine theta whole square. Okay, so we are having square here. At the place of our dx we are going to write a cos theta d theta. So it is going to be a cos theta d theta. Alright, now we are going to apply the powers here in a manual way. So it is going to be a cube sine cube theta. It's going to be a cube sine cube theta. This is my a cos theta written as it is, with a visible dot here representing multiplication. Okay, so we have to be very the representation should be very illegible. So now it is our a square minus a square sine square theta. Alright, now a cubed, once it gets multiplied with this a, it becomes a power 4. And over here you can see that inside the radical I'm having a square common. Okay, so I'm going to take it out. This is my a4 in the numerator outside. Sine cube theta cos theta d theta upon under root a square is common, and this is going to be written inside the parentheses. Okay, you know that this is your 1 minus sine square theta is equivalent to your cos square theta with respect to this trigonometric relationship. You might be aware of this. So 1 minus sine square theta is equals to cos square theta. So I'm going to take the help of this relationship here at this step. So once when this a square will come outside the square root, it'll be just a. So I'm going to write over here, right below this, your a power 4. Okay, so let me organize the page now. So it'll be a power 4 upon a sine cube theta cos theta upon under root, this is my cos square theta d theta. This is going to be cancelled, just a cube is going to be left. This is it. Sine cube theta cos theta upon the square root of your cos square theta will transform it into simple cos theta, and this is it. So this cos theta and this cos theta will get cancelled obviously, and you're having simply sine cube theta in the integrand, and then we are going to evaluate that. So this is something that is so left here. This is your cube. Now we are going to break this sine cube theta in the form of sine square theta dot sine theta d theta. Now once again we are going to use this relationship that our sine square theta is equals to 1 minus cos square theta. Okay, so I'm going to replace my sine square theta by means of 1 minus cos square theta. So I'm going to have this 1 minus cos square theta sine theta d theta. Okay, I'm going to multiply the sine theta with my 1 and cos square theta 1 by 1. So it is going to give me integral sine theta minus cos square theta sine theta d theta. Now I'm going to apply the integral individually on these two terms of the integrand. Okay, so I'm going to write this a cube outside, some nice bracket, and then integral of sine theta d theta minus integral of my cos square theta sine theta d theta, close the bracket. Now this thing can easily be integrated directly by means of the formula. Over here we are going to use simple substitution. Okay, so this thing can be helped out easily. Over here I'm going to apply the substitutions. I'm going to assume that let my cos theta is equal to some variable, any variable of your choice. So let my cos theta is equal to some variable. People are very addict of using u substitution, though there is no such restriction of using u all the time, but let me use u here. People usually like it. So this is it, and then we differentiate both sides with respect to our variable theta, the original variable here. So I'm going to differentiate both sides with my theta. Okay, this thing gives me minus sine theta. The derivative of your cos theta is minus sine theta. So it is minus sine theta, and this d theta will go over here, equal to du. Okay, and I can also write that my sine theta d theta is equals to minus du. I can shift this minus sign over here. Like this. Now I'm going to put the work over here. So this is my direct integration. The integral of your sine theta is equals to minus cos theta. You can see the formula list, and over here it is u squared. At the place of my sine theta d theta, I'm going to put my negative du. So negative of du. Okay, this negative and this negative will become positive. So it is minus cos theta plus integral u squared du. Okay, so this thing gives me the formula of integral of xn. I'm going to apply over here. It's too noisy outside. Okay, now this is going to be my u cube upon cube plus some constant. Okay, now I'm going to put my restoration. As you know that your u was actually equal to your cos theta, so restore the cos theta over here at this position. So a cube is equal to minus cos theta plus cos cube theta upon 3 plus some constant. Okay, now we are going to restore our x, which was the original variable, you can see here. Okay, so you see our x was equal to a sine theta, and over here we're not having any sine theta here, so we are going to bring our sine theta by means of the formulas of trigonometric basic formulas. So you see that cos theta, your cos theta is equal to 1 minus sine squared theta under root. It's equal to 1 minus sine squared theta under root, and cos cube theta can be obtained by using this stuff. Okay, because you know that this thing is cos squared theta, and cos squared theta power 3 by 2. Over here we can do it like this. This and this gets cancelled. You are having cos cube theta. So cos cube theta can be interpreted like this. Now you're having a sine squared theta here, and you know that your sine theta, simply a sine theta, is equals to x upon a. Sine theta is equal to x upon a. So wherever you are having your sine, you're going to put x upon a over there. Okay, so it is going to be minus radical 1 minus sine squared theta means it is x squared upon a squared plus 1 upon 3, and over here once again x squared upon a squared whole power 3 by 2 plus some constant. Okay, so now we are going to make a little more modification, and we are going to give a final shape, and we are going to take the LCM over here and here. Okay, and finally we're going to get our answer then. So let's come to the next page. Okay, so this is the next page. Now we are going to make an LCM work. My page is moving badly, let me fix it. Okay, now on taking the LCM, I'm having stuff like this. I hope the viewers are very much strong in maintaining the LCM work and maintaining the addition and subtraction of the fractions. So I don't think that I need to put more elaboration regarding this. Okay, now you see when this a square will come outside the radical and becomes 1 upon a, and when this a square will come outside the radical and become 1 upon a cube. So this power 3 by 2 is going to be applied on the numerator and on the denominator individually like this. And you can see when the power overlap, they are getting multiplied. So 2 multiplied by 3 by 2, this and this gets cancelled as the a cube is over here. Okay, so this cube is going to be multiplied with this term and with this term and with this term. So you are having now a cube minus a cube upon a under root a square minus x square plus a cube upon 3a cube a square minus x square whole power 3 by 2 plus a cube into constant. You know that a is also a constant number, so once when a constant number is getting multiplied with the integral constant, you are getting a constant, another constant value. So you can represent that constant value either by some other variable, or by c prime, or by k, or anything you want. So finally the answer comes out to be minus a square under root a square minus x square plus 1 upon 3 a square minus x square 3 by 2 plus some constant. Okay, I've just replaced the product of these two constant numbers by means of this. So this is the answer of our integral, which was this. Okay, by means of TRIG-SUB methodology, that's how you evaluate an integrand having this type. Okay, so this was the example of your indefinite integral. Let's move ahead to the example dealing with the definite integral, means the integral having limits upper and lower. So let's take and have a look over there. Okay, so here you go, another example. You can see that you are having integral limits, and at the place of your a, your a square, you are having 16, so it is going to be replaced by your 4 square. So this thing is going to tell me that my a is 4. It is going to be 4. Okay, so you are having a type of this format here in the integrand. So you're going to replace your y by 4 sine theta or by 4 cos theta. Okay, so I'm going to assume that let my y is equal to 4 sine theta. Alright, so now I'm going to differentiate both sides by means of my original variable y. So on differentiating both sides by means of original variable y, you are going to have, excuse me, it's going to be derivative of your sine theta is cos theta is d theta upon dy. So finally your dy, this dy will go over here, so this dy is equals to 4 cos theta d theta. Now this thing is helped out. At the place of your y, you're going to write 4 sine theta. At the place of your dy, you're going to write 4 cos theta d theta. What about the limits? Okay, so you see, you can either you can change the limit in exactly at this step, or you can simply solve the entire integrand, and then you restore the original variable back, and then you put down the limit. This is your choice. So for me, I find myself much convenient or comfortable in changing the limit exactly at this step. So I'm going to change my limits. So if your y is equal to 0, okay, I'm just changing my lower limit. If my y is 0, then my theta is going to be what? That's the story. So you see, at the place of my y, I'm going to put my 0. This 4 will go in the denominator. It becomes 0 upon 4 equal to your sine theta. So this is entirely 0. So this thing tells me that my sine theta is equals to my 0. So I'm going to take the inverse of my 0. This thing is going to give me the value of my theta. Sine inverse 0 is 0. Okay, so if my y is 0, then my theta is also 0. This is the first change in the lower limit. Now just talk about your upper limit. So if your y is 2, then your sine theta will be equal to y upon 4, which is 2 upon 4, which is equals to your 1 upon 2, which is 0.5. So once when you take the inverse of your 0.5, okay, so it is going to be the inverse of your 0.5. I think it's 30. So let me confirm this thing. So it is equals to your 30 degrees. So while converting it into radians, it is equal to your pi by 6. Yeah. So now I have just changed my limits. Now I'm going to give a new form of my integral, and then I'm going to evaluate this. So let's change the page and let's carry on the work. Okay, so at the place of my 0, I'm going to put my 0, because if y is 0, my theta is 0. If my y is 2, then my theta is going to be pi by 4. So this equals to your pi by 6. At the place of my y cube, I'm going to put 4 sine theta whole cube. Okay, alright, and at the place of my y square, I'm going to put 4 sine theta whole square, and at the place of my dy, I'm going to put 4 cos theta d theta. That's it. Alright, so now you see your 4 cube is 64, and 64 into 4, whatever it is, I'm going to write it outside the integral. This is what is left in the numerator, and then inside, you know that you're having 16 sine squared theta, so 16 is going to be taken common outside, and I'm having this sine squared theta left inside. Okay, and when this 16 will come outside the radical, it becomes 4. So that's how it looks like. I'm sorry, I just forgot to write my 64, and this is my 4, and this 4 will come outside. 0 and pi by 6. This is my sine cube theta cos theta upon this thing is equal to your cos square theta. So under root cos square theta d theta. This 4 and this will get cancelled. You're simply having 64 here left. Okay. 0 and pi by 6. You're having sine cube theta cos theta upon cos theta d theta. This cos and this cos will get cancelled, and now finally you're having 64, 0, pi by 6, sine cube theta d theta. Now same thing that we did in the previous example, we are having same thing back. So now I'm simply going to write down the answer instead of doing the whole process. So I'm having this answer left. I was having minus cos theta plus cos cube theta upon 3, and this is the limit with respect to your theta. Okay, now you do not need to restore your theta back to your y, because this is a definite integral and we have transformed the limits as well with respect to theta. Now you're simply going to apply the limits and you're going to get the answers. Okay, so first apply the upper limit. It's going to be minus cos pi by 6 plus cos cube pi by 6 1 upon 3, right in the small bracket, and then minus, apply the lower limit, minus cos 0 plus 1 upon 3 cos cube 0, close it, big bracket close. Okay, you know that the cosine of 0 is 1, and cosine of 30 is under root 3 by 2. Okay, so the answer is minus under root 3 by 2 plus 1 upon 3 under root 3 by 2 whole cube. Alright, and then minus minus plus, cos 0 is 1, minus plus minus 1 upon 3 into 1 cube. That's it. So once when you just apply this cube power on the numerator under root 3, you're getting power 3 by 2, and this power applies on the denominator too. You are getting 2 power cube, which is 8, and 8 gets multiplied with this 3. This is plus 1 and this is minus 1 upon 3. Now we are going to simplify this entire stuff. And also we can write 3 power 3 by 2 in the form of 3 under root 3 upon 23 into 8. And on taking the LCM of this 1 and 1 upon 3, you're getting 3 minus 1 upon 3, which is 2 upon 3 finally. And this 3 gets cancelled. So minus under root 3 upon 2 plus under root 3 upon 8 plus 2 by 3. Okay. So let us now take the LCM of this 8, 3, and 2. So 2, 3, 8 LCM. So this is your 8 and 3, 24 is your LCM. Sorry. This is your 24, this is your LCM. And then this thing comes out to be your 12 under root 3 plus 3 under root 3 plus, it's going to be 16. Okay, this 64 upon 24. And it gives you 16 minus 9 under root 3. Alright, this thing can be simplified. You see that 8 the 64 and 8 3 the 24. So 8 upon 3 into 16 minus 9 under root 3. Alright, so this is the answer of this integral with the help of your trigonometric substitution of type a square minus x square. So that's all for today. I hope you find this video helpful, and if really you do, then I humbly request you to subscribe my channel, hit on the like, and share this video as much as you can with the other learners, and try to put down your feedback in the comment box. Take good care of yourself. Allah Hafiz.